Hello and welcome to another GCSE revision video, and in this video we're going to be looking at the names and properties of two-dimensional shapes. Now the word polygon has absolutely nothing to do with a missing parrot. Polygon comes from the Greek word poly, meaning many, and gon, meaning angle. So the Greek word polygon means many angles. Now a triangle has three angles, so we can call a triangle a trigon. In fact, the suffix metri comes from the Greek meaning to measure. So the word trigonometry actually comes from the Greek words three, angles and measure. So trigonometry is the measurement of three angled shapes. Now there's certain words that you really should know. Now, it doesn't matter if you remember the Greek and Latin root words, but you do need to know the names of certain shapes for your exam. So tri, as in tricycle, means three. So a triangle has three angles, which means it also has three sides. The word tetra in Greek and quad in Latin both mean four. So a tetragon or quadrilateral has four angles and four sides. The word penta means five, so a pentagon has five sides or five angles. A hexagon similarly has six sides and six angles, and hexa is Greek for six. Now, hepta in Greek and septa in Latin both mean seven, so a heptagon has seven sides and seven angles. Octo, as in octopus, has eight, or octo as actually means eight in Greek, so an octagon has eight angles and therefore has eight sides. Nono is nine, so a nonagon has nine angles or nine sides. A decagon has 10 sides and 10 angles. A polygon has many sides and many angles. I'm pretty sure those are the only ones you really need to know for your exam. You may well be given a shape and you'll have to count the number of sides and then name that shape. So you might be given a six-sided shape and asked to name it, and they will expect you to know that it's a hexagon. Or they might give you an eight-sided shape and you're expected to know that it's an octagon, and so on. Now in maths we don't like the word corner because it's a bit ambiguous. So we tend to say that where two edges meet, that's a vertex. It's basically the pointy bit. The plural of vertex is vertices. Now a triangle has three edges or three sides and three vertices and three angles. Now a quadrilateral has four edges or sides and four vertices and four angles. In fact, for any two-dimensional polygon, the number of angles is equal to the number of vertices, which is equal to the number of edges. Now the internal angles of a triangle add up to 180 degrees. Okay, just in case that last point wasn't obvious, let's just construct a triangle, any old triangle. And in what I'm going to do now, I'm going to extend the lines. See if I can extend this line a little bit better. So these are straight lines. And I'm going to draw a line parallel to the base of the triangle. Okay, so we have our three angles here. This is angle A. This is angle B. And this is angle C. So what we know about parallel lines? This line is parallel to this line. Well, we can say that vertically opposite angles are equal. So this angle here is the same as angle C. Now, if this straight line intersects with this line at angle A, then it must also cross this line with the same angle, because these two lines are parallel. And the exact same argument can be said for angle B. This line is parallel to this line, therefore this straight line must intersect both angles at the same both lines at the same angle. So angles B plus C plus A, because they fall on a straight line, must add up to 180 degrees. It's as simple as that. A quadrilateral can be divided into two triangles. So the sum of the internal angles is 2 times 180 degrees, which is 360 degrees. A pentagon can be divided into 3 triangles. So the sum of the internal angles is 3 times 180 degrees, which is 540 degrees. And a hexagon can be divided into 4 triangles. So the sum of the internal angles is 4 times 180 degrees, which is 720 degrees. In fact, any n-sided convex polygon can be divided into n-2 triangles. So the sum of the internal angles is 180 into n-2 degrees. Now the exterior angle is the angle you get when you extend one of the lines of a polygon and then measure the angle from that line to the other line. So by definition, the exterior angles and interior angles of a polygon must be supplementary. That is to say, they must add up to 180 degrees. Now to find the sum of the exterior angles, let's say that the exterior angle is called E and the interior angle is called I. Now, as we've just discussed, I plus E is equal to 180 degrees. That is to say, the sum of the interior and external angles must add up to 180 degrees. Now, if we rearrange that, we can say that the exterior angle is equal to 180 degrees minus the interior angle, or more algebraically, E is equal to 180 degrees minus I. Now again, as we've already said, the sum of the interior angles is 180 degrees multiplied by n-2. That is to say, the number of angles minus 2. That's because we can make n-2 triangles out of an n-sided polygon. Now, the sum of the interior angles can be expressed as n times I, so we can say n times I is equal to 180 degrees into n-2. Now, if we expand out those brackets by multiplying 180 degrees times the n and then 180 degrees times the negative 2, we get n times I is equal to 180 degrees times n minus 360 degrees. And we can rearrange that to get 360 degrees is equal to 180 degrees times n minus n times I. Literally all I've done there is move the n times I from the left hand side to the right hand side by subtracting n times I from both sides of the equation, and I've added 360 degrees to both sides of the equation so that I can move the 360 degrees from the right hand side to the left hand side. Now by factoring out the n, we can say 360 degrees is equal to n into 180 degrees minus I. But 180 degrees minus I is what we said the definition of was for the exterior angle E. So 360 degrees is actually equal to n times E. And n times E is the sum of the exterior angles. Therefore, the sum of the exterior angles of any convex regular polygon is 360 degrees. So to summarise, the exterior angle of any regular convex polygon is 360 degrees divided by the number of angles, which is the same as the number of sides, which is also the same as the number of vertices. And the sum of all the exterior angles of any convex regular polygon is 360 degrees. The sum of the interior angles is 180 degrees into n minus 2, again where n is the number of angles or the number of sides or the number of vertices. And the interior angle is 180 degrees into n minus 2 divided by n. Okay, I hope you found that helpful. I'd like to wish you all the best with your revision and all the best with your exams, especially if you're taking them this year. Don't forget to like, comment and subscribe, and I look forward to seeing you in another video.